Probstats kids, this is Dr. Callahan with week 16 Monday. How are you guys doing? I hope you had a wonderful weekend. Go ahead and pause the video and answer the following 3 questions for your warm-up blog. All right, you guys, so today you guys have the following as your guided notes. So we're going to go over this together with the optimal Hamilton circuit and the brute force method. So it's a continuation of our unit on circuits. All right. So this is what the brute force method is. You basically make a list of all the possible Hamilton circuits for each of the circuit. In the list, you're going to calculate the weight of the circuit, and the weights are basically the amount it costs to travel from point A to point B. From all the circuits, you're going to choose a circuit with the least total weight. And this is going to be your optimal tour, which makes sense because it's also going to be the least expensive cost to travel from point A to point B. The only way to find an optimal Hamilton circuit is to actually follow all the possible circuits. So unfortunately, you can't just use n-1 factorial. You will literally have to check the cost one by one. This is called the brute force method, which I figured is rightfully so and very appropriate. It is very time consuming and is considered to be the optimal but inefficient nonetheless. So here, Willie's graph has 5 vertex. How many circuits would you have to check? So using the circuit formula, which is basically 5 minus 1 factorial, which gives you 4 factorial, that means you will have to take 4 times 3 times 2 times 1, which means there are 24 Hamilton circuits. And so looking at this, we would have to use the brute force method by listing the 24 Hamilton circuits and then adding up the cost of all the possible circuits and then selecting the one that is the least expensive. So really it is a 12 plus 12 mirror images. So all you have to do is find the first 12 circuits and then you basically just flip the routes to create the mirror images. And remember when you create the mirror images, the ending and starting points are exactly the same, but the 4 different points in between them are reversed. So rather than have you guys do all of that, just keep in mind that this is the 12 that is listed. And if you take a look over here, this is the total cost that is being calculated. And so looking at this, which one is the most optimal or which one is the least expensive route with the 12 different Hamilton circuit? You should say A, D, B, C, E, A, which is the route 11 because it's only $676. Or what you can do is, remember when you guys do the reverse of this or the mirror image of this, the first and last endpoint is always going to be the same. So if you start at A, you know you're going to end at A because it is a circuit. But then what does change are the number or the letters in between. So here E comes first, then C, then B, and then D, because it is reversed. So the total weight is $676, and that is the optimal tour with brute force method. All right, let's go and take a look at example 1. It says find the optimal Hamilton circuit for the following graph. Use the brute force method. Write your answer as A as a reference point. So you start at A, it's just going to be A, B, C, D. A, B, C, D, A, that's in the first one. Another route could be the reverse of that, which is you can still start at A, but it'll be A, D, C, B, A. And if you take a look, all you're doing is just reversing it. And so if I take a look at this part here, you're going to be calculating the total. And if you're like, how'd you get 43? It is just from A to B, which is 10, B to C, which is 14, C to D, which is 7, and then D back to A, which is 12, which gives you 43. All right, go ahead and pause the video and do the next one and this one here. For the second one, you should be able to see that it's going to be DCA. And if you reverse that, it'll just be ACDBA. And the total route, if you add everything together, from AB, it is going to be 10. From BD, it is going to be 10. From DC, it is going to be 7. and DA, it is 12. So 10, 10, 7, and 12, which gives you 35. Next one over here, ACBDA, or the reverse, which is going to give you 44. So which one is the most optimal? It will be the middle one because it's only 35. All right, let's take a look at this one here. Now I have 1, 2, and 3. Go ahead and list the optimal circuit and then provide me with the weight. For the first one, you could do ABCDA and then AB or ADCBA, which is the reverse. If you look at the cost over here, AB is 10, BC is 6, CD is 2, and then DA is 4, which then gives you a total of 22. Next one, you could do A, B, D, C, A, and the reverse of that. So then AB is 10, BD is 3, DC is 2, and CA is 5. That one here is going to give you a 20. The next one is going to be A, C, B, D, A. And so altogether, it's going to give you this right here, 18. And so the most optimal one will be this one because it is the least expensive. Now, just to check to make sure that you know how many different mirror images you will have, looking at this right here, since you have 4 vertex, 4 minus 1 gives me 3. 3 times 2 times 1 is 6. So it is 6 circuits. And then you could do 3 and 3. So here is 1, 2, 3. And then 3 of the mirror images. So that's 4, 5, and 6, which then means you have a total of 6 circuits altogether. All right, let's go ahead and look at example 3. Find the optimal Hamilton circuits and its weight. And so here you have Indiana, LAX, MSP, and RSW. These are all airports. I don't know what RSW is. LAX, I definitely know it's in Los Angeles, but the rest of them, I'm not quite sure. But let's go ahead and take a look at them. So to find the number of circuits, you have 1, 2, 3, 4. So 4 minus 1, so 3 times 2 times 1, which is still going to be 3 mirror image circuits. So first one I'm going to do, I'm going to do IRLM. So here is my first one, and I put the weighted amount of money it costs to travel in between them right here. And then so you look at IRLMI. And then of course you can do the same, but then you just simply reverse it. And the total cost of this, if I were to add these numbers together, it will give me 1,062. And then of course I can go ahead and do a different route, which in this case is IRML. And then I can also reverse it. So I could be a RLMRI. And then adding the cost together, it will give me 1,043. And then of course, the very last one, you can go ahead and put it in this direction. And altogether, which one is the most optimal circuit? It will be this one here for $1,043 if you were to go to all 4 different airports. All right, guys, now I'm going to take a look at the second page. So you just need to flip this over to the back. Okay, brute force takes too long for anything that's going to be in greater than 4. So if you have like 5 or maybe 100 circuits, could you imagine like doing 100 minus 1, which is 99 times 98 times 97 times 96? I mean, that's just way, way too long. So we need a faster way to come up with a good answer. This is the nearest neighbor algorithm. So you basically start with the designated vertex. So in this situation, it could be A. Okay. If there is no designated starting vertex, you can pick any vertex. So most likely it's going to be A. First step is from the starting vertex, go to its nearest neighbor and the vertex for which the corresponding edge has the smallest weight, or I guess in this cheapest. So shortest for the nearest. The middle step from each vertex, go to the next nearest, which is also going to be the shortest neighbor among the vertex that haven't been visited yet, and keep doing this until all the vertices have been visited. And the very last step is from the last vertex, return to the starting point, which is going to be point A, and the tour we get is called the nearest neighbor tour. So then looking at this example here with Willie, or with the traveling businessman, use a nearest neighbor algorithm starting with vertex A to find a Hamilton circuit in its way. So if I look at A, which letter here is going to be the next shortest or the less expensive? And I think it's going to be C. And it is, because you have A to C, so it's $119. And then from C, which one's closest to C, or the cheapest from C? From C, I can go to D because it's only $120. So 120. And then from E, which one is closest? In this situation, you can't really go back to A because we're not done with all the circuits yet. So from A, we go to C. From C, we go to E. And then from E, you want to go probably to D because that's the next closest and the least expensive. And then from D, I'm going to go over to B because it's 174 if I were to go to C, but I already been to C. I can't go back to A. So at D, I would have to go back to B, which is $150. And then from B, you want to go back to A because I've met all the points. So then adding everything together, the total is $773. And that, you guys, is the nearest neighbor algorithm in case you do have something that is more than 4 points. So in this situation, there's 1, 2, 3, 4, 5 points. So n equals 5. This is the nearest neighbor algorithm. All right, notice that our answer is not optimal answer, but the process to find it is relatively quick. So Willie Loman decided to decide if the time he saved by doing the brute force method is worth the money he loses from the difference. So we say that the nearest neighbor method is the approximate and efficient. But what if Willie Loman's territory get expanded to 10 different cities? Holy moly. First, we have to tell yourself how many different Hamilton circuits are on the graph. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n equals 10. 10 minus 1 is 9. So 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is 362,880 circuits. Does that mean I am going to divide that by 2 and then write down, potentially, excuse me, 180,000 different mirror images of each other? No, that's absolutely crazy. How many edges are a part of this graph? I mean, if you're to count all the edges, you can, but a better way of doing this is by using the formula n times n minus 1 divided by 2. So then I just plug this in as 10 times 9 divided by 2, which is 45 edges. So a more practical way to organize this table when you have 10 different vertex like this one is to order it into a matrix, just like when we did the adjacent matrices. This is a good way to do it this way, okay? So we created this, and luckily I didn't have you guys do it because I was going to do it for you. You're going to use the nearest neighbor algorithm to find the Hamilton circuit starting with A. So from A, looking over here, okay, which one is going to be the least expensive route from A going all the way down? So A to B, A to C, A to D, A to et cetera, et cetera. Well, the cheapest route that you can see here is A to C, which is $119. Okay. Then I'm going to go compare from C and looking at C. So we're done with A. So cross that out. I now look at C because that's the second one, looking at all the prices here. You can't go C to A because we're already done that. So we're going to look at which cost that we have not used yet, 120. So from C to E is 120. Okay, so I'm going to cross out C. And my third one is to E. Looking at E, which one's the least expensive, and it looks like 199 is that. So from E to D is $199. So done with E. So cross that out. And then we're going to go on to the next one, which is my fourth one, and that's going to be from D. So here we go. Which one's the least expensive? It is going to be 150 because remember, we've already done all of A, so we can't use A. We cannot use E. We cannot use C. So then that will be B. So from D to B, it's 150. And then continue on with this trend until you find the least expensive one with all 10 of them. So this is kind of where it's at 150, 379, 241, and then 235, and then 222, 211, and lastly 277. And when I add everything together here and find the sum, it is going to give me a total of $2,153, and that is it. Okay, use the nearest neighbor method to find a Hamilton circuit starting with the vertex A. Use the nearest neighbor method to find a Hamilton circuit starting with the vertex B. So I'll do A with you guys. If you take a look at A, the nearest one is going to be from A to B because that's only one. And then from B, I can go to probably D because that is the second cheapest one. So here's 1, 2. From D, I want to can't go back to A because we're not done with everything yet, to C, which is going to be 4. And then from C, I go back to A, which is then 6. And then here's your answer for B. The chart below represents the price of a bus ticket. Follow the following city. You will need to start in your hometown of Z, find the Hamilton circuit and its weight. So go ahead and give it a try. And take a look at my answer here. So looking at this, you start off with Z. So this is my first one. Which one's the cheapest? Z to W, Z to V, Z to X, Z to Y, Z to Z. Well, can't do Z to Z. So Z to V is only 45 bucks. So Z goes to V. So $45. Okay. So then I am done with this column. Cross it out and we're done with V. So here we go. Next one I'm going to do is I'm going to take a look at the second one, which is V. Okay. So which one's the cheapest? V to W, V to X, V to Y, V to Z. The cheapest one here is $10, which is X. So then I'm going to cross out the V, cross out the X. And then I go to the X, which is right over here, which is my third one. And then I look at, okay, X to W, X to Y, X to Z, which actually Z is done, just kidding. Which one's the least expensive? It will be X to Y, which is $30. So, oops, cross out the Y. Cross out the X. And then I have, let's see, a Z to Y. So I'm gonna start off with Y, and looking at Y, I'm gonna ask myself, okay, which one? Well, it's only one option, so $37 is that. And then go back to Z, which is gonna give me, so Y, or W to Z is $60. Here we go. Adding everything together, $182 is your optimal circuit. Okay, so then let's take a look at this right here. So your video I want you guys to watch is called Hamiltonian Circuit Problem Using Backtracking. It is about 8 minutes, so you can either type in this URL right here, or you can go ahead and just Google this part into YouTube. So Google this piece right here and watch the video. When you're done with the video, ask yourself and write this down. What is your definition of a Hamilton circuit and Hamilton path? Next, can you recall the formula for finding the number of edges, finding the number of sort of circuits? And lastly, I want you guys to go ahead and take a look at just this piece right here and answer the following survey questions when it comes to your study habits. All right, you guys, as always, I hope you have a wonderful week. I'll see you guys next time. Take care.